We are Group 4, and our project title is Demand Forecasting for E-commerce Products. So this is our project background, domain, and scope. We'll be focusing on Pakistan e-commerce. We'll be using EDA, data imputation, clustering, and some forecasting models like SARIMA and LSTM to analyze historical transactional data to find patterns and trends. Our target organization will be large e-commerce platform like Shopify, Daraz, and Shopon. Next slide, please. We identified a few problems. So one main one is that large-scale promotions or event, which cause unpredictable demand surges. Another problem is that the payment method is mainly by cash, so that influences customer behaviors. From research papers, we also see that most studies focus on China and India's dataset, so there's no Pakistan-focused study. And with the problem, it comes to objectives. So we would like to forecast the order volume for the top 3 product categories, analyze the impact of major sales on order, analyze the impact of COD dominance, and to compare different forecasting models and measure their performance. Next, I'll pass on to Rakib.
Thank you, Golden. For literature analysis, I first did the critical analysis. I researched papers from Scopus and selected 3 research articles and 1 conference paper. At first, I have formatted all the data in tabular format. So from these 4 papers, we have found researchers have used time series models like ARIMA, advanced machine learning models like LSTM, GAN, clustering techniques, and hybrid models. Among those, GAN and long short-term memory outperform other traditional models. Hybrid models like GCN, LSTM attention models also show significant improvements. So the limitations, actually researchers have faced difficulties with data quality and volatility. Models like ARIMA struggle with handling non-linearities and complex dynamics. Using advanced hybrid models turn out to be computationally intensive. To overcome these limitations, researchers have suggested to develop more accurate and robust models. Secondly, future work can be done focusing on refining model architecture. And last, more sophisticated techniques for feature selection and engineering are needed. So in next phase, when we will going to build our model, we will try to implement all these improvements. I will pass to Ray.
Okay, so for the data collection, our data source is Pakistan's largest e-commerce data set, which is an open data source that we get from Kaggle. And the number of observations in this data sets includes like 584,534 rows with 21 columns that have like detailed information for e-commerce transactions data. For the data scrubbing part, we remove like rows that actually have like null and invalid value, but we only do it if the number of rows is less than 0.01% of total rows, so that it won't reduce our model accuracy as well. Apart from removing rows, we also remove columns that are actually like redundant and inaccurate, such as like grand total and also like a working date. Apart from removing, we also do imputation using the hot-tag imputation for category data, which we notice that have like a large number of missing rows, which is 8,014. So how we do it is we cluster the SKUs into like keywords. Then from those keywords, we choose the most likely category based on the number of SKUs that have that category. And from there, we impute the missing category's name. From there, we can actually impute 96% of the missing values, and the remaining 318 we classified as null. Moving on to EDA part.
Now I'll be walking through the exploratory data analysis. So the monthly demand trend chart reveals consistent transaction spikes each November, most notably in 2017, likely driven by the 11/11 campaign. An additional peak occurred in the March 2018, possibly linked to clearance or promotional events. Next, we analyze the quantity ordered by category. Mobiles and tablets emerge as the top performing segments, while niche categories like health, sports, and books showed lower demand. We also examined the monthly trends of the top 5 SKUs. Most showed brief demand spikes linked to promotions, particularly in May 2018. However, one SKU stood out consistently. making it ideal for demand forecasting and inventory planning. We also compared total discounts with quantity ordered and found a clear trend. Months with heavy discounts such as November 2016 and March 2018 saw higher sales. So for payment method usage, this chart shows the top 10 payment methods, and cash on delivery clearly dominates, reflecting customers' preference for postpaid payment. The matrix shows a moderate positive correlation between price and discount amount, but little to no correlation between discount and quantity ordered, suggesting that discounts alone don't reliably drive higher order volumes across all products. To conclude, our ADA reveals that demand is seasonal and campaign-driven, with tech and fashion leading in sales. Most products experience short-lived spikes, and while discounts impact demand, the effect isn't always linear. Cash on delivery also remains as the top payment method, which is an important factor for both operations and marketing.
For this part, we focus on two areas. First, the ethical aspect, how we handle the data, and the second is the real-world impact this project will have on society, especially on e-commerce ecosystem in Pakistan. There is no personal customer data, no names, no phone number or addresses. This data only include order ID, product, or order details. Only customer identities are protected. So we also handle the data. We use hot tag imputation for 7,696 rows to fill in missing product categories. Also, we avoid misuse of data. Forecasting is done at the product category level, not individual levels. This avoids ethical risks like targeting or exploitation. For e-commerce, for impact society, for the e-commerce companies, accurate demand forecasting help prepare for high demand periods, reduce stock out, increase revenue, and improve service reliability. For sellers can afford overstocking or missing out on key sales events, help reduce inventory holding costs and prevent losses. For customers, products are more likely to be available during sales period. For the environment, reducing overproduction and excess inventory means less material waste. Also lowers energy use from unnecessary storage and transportation. In short, this project respects data ethics and delivers real-world benefits to business, sellers, customers, and even the environment. Thank you.